Hey guys, Avi here, and welcome back to our Python programming series. In this video, we're going to dive into our understanding of object-oriented programming, specifically the concept of inheritance. Let's use a real-life analogy to grasp this better. Imagine a car manufacturing company. They make a base model car with common features, like an engine, wheels, seats, and so on. Now they also produce variations of this base model, such as a sports version with a more powerful engine or a luxury version with high-end seats. These variations inherit the common features from the base model, but also add or modify some features. That's exactly how inheritance works in programming for classes too. First of all, let's go ahead and create a base class. We're going to call this car and define some basic methods. So we have here class car. In our init method, we're going to say def init self.wheels is equal to 4, and self.seats is equal to 5. So our base model car has 4 wheels and 5 seats. That's awesome. Let's also define a drive function. So let's say def drive self, and inside of this drive function for now, let's just say we're printing, we're driving a car. So print driving a car. Now, if we instantiate the car class and call the drive method, what happens? Well, let's define my car is equal to car in parentheses. So we have an instance of car now. And then let's call my car.drive. This will print driving a car. Fantastic. So now we have our base class car with 2 attributes, wheels and seats, and a method called drive. Next, let's create a sporty car class that inherits from the car class. This sporty car class will have more powerful engines and fewer seats. So the way you go ahead and inherit a class is by defining it in the class definition. You pass in class sports car, and then in parentheses, which class you're inheriting from, which is the car class. Inside of our init method, we're going to go ahead and call a unique function, super.init. And then we're going to set self.enginePower equals 400 HP, and self.seats is equal to 2. And then, continuing on, in our drive function, let's go ahead and reinitialize our drive function to say print driving a sports car. The super.init function call is used to execute the init method of the parent car class, ensuring that we don't lose the attributes initialized there. The sports car class then modifies the seats attribute and adds a new one specifically for the sports car called engine power. Now, let's go ahead and create a sports car object and call the drive method. My sports car is equal to sports car in parentheses, initializing our car. And then let's go ahead and call my sports car.drive. If you go ahead and call this method, it prints out driving a sports car. Notice that we've actually overridden the drive method in the sports car class. This means that when we call drive on a sports car object, it will execute the sports car class's version of the method, not the car class's version. If we didn't specify the drive method in sports car, we could have easily called .drive on our sports car object, and it would have simply printed driving a car. And it would have gotten that function from the original parent class, which is the car class. So that is inheritance in a nutshell. What we've done is sports car has inherited the base attributes and functions of the car class. In this case, it had inherited wheels being 4, seats equals 5, and the drive function, and then it chose to override some of these values. Seats was then set to 2 instead of 5, and the drive function was overridden to say driving a sports car instead of driving a car. So why is this important? Well, there are 3 key reasons. Number 1, reusability of code. In our car example, we didn't have to rewrite the attributes for wheels and seats for the sports car. We could inherit them from the car class. This also allows for easy maintenance and updates. If we wanted to change a common feature across all car types, we just need to change it in the car class, and the subclasses will inherit the changes. And last but not least, organized structure. It makes logical sense to have a base car class and then subclasses for different types of cars. It makes our code easier to understand and manage. I hope this has made inheritance in Python clear. Inheritance is a very powerful tool for creating organized, reusable, and easy to maintain code. That's it for inheritance in this video, guys. Thanks so much for listening, and I'll see you in the next video.